All right, everybody, welcome. I'm recording again, which means it's time to start. I hope you enjoyed your break. I know I did. I spent most of the for some relevant articles to show. So, a lot of people ask me, why Python? Why not R? Why not Java? Why are we doing this in another language? And truth be told, this class used to be taught, at least in DC, used to be taught in both R and Python, and to do both side by side. We have since chosen to, again in DC, and I don't know how it was here in the past, to do only in Python. And there are many reasons for that. One of which is that it is one of the most popular coding languages in the world. As you can see, Java and Python hold a very large share of the coding base in the world, as well as the third being JavaScript. One of the reasons for that is that Java used to be the dominating language in the object-oriented and the programming world. IBM's code base, Microsoft's code base are all built on a Java framework. Watson, that smart Jeopardy-playing computer turned business intelligence supercomputer, is built primarily in Java. Python is a rapidly growing language. In fact, it is now one of the top introductory languages taught in major US universities. It used to be Java. I taught Java for 2 years in university, and now people have started switching over to teaching Python instead of Java, sometimes alongside. There are many articles you can read that are very recent and relevant, talking about the #1 programming languages to learn: JavaScript, Java, Python, CSS, which is a front-end language, PHP, which is a very back-end language. But Python is one of those languages that's good for a lot of things. It's good for small scripts, it's good for data science, it's good for web development, front-end, back-end. Python is a very versatile language, which is why we're doing it in this class. Just as a little side note. And there was another article I couldn't find that was actually showing how Python has actually become the fastest growing academic language, as in they were tracking the rate of usage of citations of coding languages in published papers, and that Python was actually overtaking languages like R and overtaking most academic languages. That Python is actually becoming the fastest growing academic language in academic papers. I thought that was also very interesting. So more and more people, whether they're PhDs in theoretical math or very applications-based data scientists or web developers, are all using Python. So just as a little motivation. All right, back to o3pandas.py. So drinks. Drinks is our data frame. So we've made a new column, we've filtered, we've sorted out, we have looked at 2 columns out of the now 7 columns we're able to get basic descriptive statistics about those columns. But now we can do some filtering and sorting. Line 75 will show us the data frame where the continent is EU. So it will only show us European countries. So line 75 automatically filters out everything where the continent is not EU. And how it works is, well, it makes this drinks.continent equals EU. And the equals notation we should be very familiar with. What does equals do? Yeah, it compares them, and it'll spit back true or false. So remember, does 5 equals 5? True. Does 5 equals 5.0? Also true. Does the string 5 equals the number 5? False. So it'll spit back true or false. But here we're doing drinks.continent equals string. What is drinks.continent? Series. What is EU? An object. An object or a string. So when you compare them, what do you expect to see? Is a series the same thing as a string? No, it's false. It should be false. However, remember, Pandas is doing things element-wise. Normally we would say series is the same as string. No, of course not. Series holds many things. A string is a string. But here, what it's doing is it's going through for each element and continent, element-wise, is it equal to EU? true or false. So the true ones are where the continent is EU. The false ones are where the continents are not EU. It's like the is null. The is null scanned the entire data frame and said, if it's null, make it true. If it's not, make it false. Here, it's scanning through continent. If it's EU, make it true. If it's not, make it false. So we end up with another series of trues and falses. And then we take those trues and falses and we put it into drinks. We say drinks, select, using the square bracket, select from this list of trues and falses. And what the filtering mechanism does is, for each true element, it will keep that row. For each false element, it will not keep that row. So what you end up doing is only taking rows where the continent is EU. So in that one line, we are filtering out the data frames to only include rows where the continent is EU, Europe. Yes?
Go back. Show me. How does it evaluate the expression? Generally, like the inner expression is evaluated as itself and then fed to the dictionary, right?
Yes, that's exactly how it works. So the inner expression here is drinks.continent equals EU. So that happens first. It will create this list of trues and falses, or a series of trues and falses. It will take those trues and falses and throw it directly into drinks selection operator. The selection will then say, okay, wherever it's true, keep that row. Wherever it's false, let it go. So it will only spit back those rows where the index is true.
Could you do a like? Could you do
like similar to like?
So let's say that this ad hadn't been cleaned yet, and some of them said EU, but some of them said Europe. Could you do like? Let's see what you could do.
A like comparison.
Yeah. Right.
So what you can do, the question is, what if they're not EU? What if it's Europe? What if it's like European Union? What if they wrote it in a different way? The short answer is, it's not a base option. The better answer is, you can create your own function. In fact, we're going to learn how to do that. You can create your own function, and that function could look for different ways of saying Europe and scan for that. Yeah?
There's kind of a base function for that, and if you just do .str.contains.
That's true. There's a contains option, but that can be tricky, because if you contain like EU, for example, if it contains EU, other things also contain the two characters EU. So that could be dangerous. But there is an option, you're right, and I think you point that out, there is an E contains option, where if it contains one of these, then it is true. And I don't have one in this code base, but you can look at an example of that. So, line 95. Let's dissect it. Drinks, country, total servings. This one part I'm highlighting. What does this do? Drinks, country, total servings with a double square bracket. What does that do? Danielle? Yeah?
It returns the country and total servings column where the continent.
Yeah, so the whole, yeah, right. So what the whole line does is it will return the country and total servings column, here now where I'm highlighting, where the continent equals NA. So if I do this, here are the countries and total servings for all countries listed in North America.
Why does it list US?
Where?
Okay.
Where is this from?
Okay.
I have not heard of many of these countries, not to be honest with you. Like St. Kitts and Nevis. Sorry, I've never heard of it. I'm not really a geography guy. But here are all the countries that the World Health Organization was able to get data on in North America. Now, line 98 is the same as line 95, except at the end, I've added a sort. Now I'm sorting, sort index, by total servings. So it's going to be the same exact data, except I'm just sorting it by total servings. by default, it will sort by in an ascending manner. So the first row is the smallest total servings, and the last row is the largest total servings. Yes?
Sort index is a native Panda function.
It's a pandas function, yeah. So it's a function in the data frame. So it's a data frame dot sort. And then you say by, and you tell it which column you want to sort by. You can also give it several columns to sort by as well. And we'll see an example of that too.
Can you also give a function for sorting?
A function for sorting?
Yeah, I mean our own custom function.
Yeah, you can actually give your own function for sorting. That's a bit of an advanced feature, which I don't have in this particular code base, but you are able to give your own function for sorting, yes. So you can say sort, yeah, it's possible. We can filter. So does someone want to tell me, or make a quick educated guess, what this line that I'm highlighting will show me? Drinks dot wine servings greater than 300. Drinks dot total liters of pure alcohol greater than 12. What will that show me? Someone, what is that going to show me? What do you think?
So it filters on two columns. Column one is wine serving. Two is milliliters of pure alcohol.
So for each of those rows, what will be the case? For each row, what can we say? They will satisfy, let me run it. So this is the row, the only row, that satisfies the condition that the wine servings is over 300 and the total liters of pure alcohol is greater than 12. Damn it, Dora. Slow down. We can also compare between columns. Line 104. Drinks where, square bracket is I am filtering or selecting, drinks.wine servings greater than drinks.beer servings. Without having any knowledge of pandas in the past, does someone want to guess and tell me what this is going to do? It's going to show me all of the countries with a greater wine serving than beer serving. So let's run it. So this is every single country who drinks more wine than beer, on average. So here we have Andorra, 312 versus 245. Argentina, 221 wine serving versus 193. Cook Islands, 74 wine versus 0 beer. Apparently there's no beer on the Cook Islands. And you get the point. So we can filter not just based on a integer, but based on each other. We can base on this column greater than this column. Any other question?
I don't think so. I'm sorry.
No, it's fine. So we're sorting, we're filtering. Let's make this in the middle again. So if I sort by beer servings, so what does the default sort by? Who remembers? Ascending. So where are the largest beer servings? Top or the bottom? The bottom. So how do you get the bottom rows? So if I sort by beer servings and then do dot tail, what will I get? Top 5 beer drinking countries. And who wins? Poland, Germany, Gabon, Czech Republic, and Namibia. 376 per person, on average per person per year. That's more than a beer a day in Namibia. All right, well, what if I want the average North American beer consumption? Average North American beer consumption. Well, what I can do is, I can do drinks.beer servings, the column, filter it where drinks.continent equals NA, North America. If I just do that, it will give me a series of beer servings, but not all of the beer servings, just the beer servings that are in North America. And then I can call a .mean function to give me 145.43. So on average in North America, a person drinks 143 beers in a year. On average in this continent.
That column that you did, the beer servings, could have been done in square brackets.
Absolutely. Great question. So the question is, this beer servings right here, what if I had done beer servings with the dictionary notation? Same thing. Exactly the same notation. Good question. Thank you. So note the procedure, and I want to break this down so you can look at it on your own later, but I'm going to go through it right now. Drinks.beer servings is a single column, beer servings. When I add this filter, I'm filtering the series based on another series. I'm filtering drinks.beer servings such that the continent is NA. And then the last thing I do is I tack on a dot mean. So I take the resulting series and I say series dot mean, and it gives me the average of that list, of that series. So a lot of pandas is kind of tacking on filters and functions after another. So I have drinks, data frame. Drinks.beer servings, column. Drinks.beer servings, filter, where drinks.content equals NA. Data frame dot column, filter dot mean. So I'm just adding on to the same line of code. And as you're doing examples in pandas, I recommend that you do it in this fashion. You start with your data frame and then keep trying to build up to what you're trying to get. So if I want the average beer consumption in North America, I would say, data frame, I want beer, drinks.beer servings. I want North America, drinks.beer servings, where drinks.content equals NA. I want the mean, dot mean. So it's a way of adding on functions one after another. And guys, oh yes, question.
When there's indexing going back to the wine servings greater than 300 and the alcohol greater than 12, is there like a computational advantage to writing it this way versus using like an and statement? I mean, I assume we can still use our logic operators inside brackets, right?
Yeah, so you can actually use, it's actually an equivalent to using the and or operator.
Yeah.
It just implicitly uses and.
Sure.
So you could write in or instead, and it would do either or. So there's no advantage because it's actually using the and or logic, the same base Python and or logic. It's just, in pandas, you don't have to write it out, because it's implicit that you mean and, unless you say otherwise. So,
No, I was just thinking that like maybe it subsets the data so you don't have to like, you're like doing less checks, like you get a really large data set or something.
oh, I see your point. So it's like, is there a computational advantage to doing it like, you mean this line, like 101, as opposed to splitting it up, like into two different calls?
Literally saying and.
As opposed to literally, that I'm not totally sure of. My gut is to say that this is computationally less expensive, so better, faster. I don't have times right now for this versus using a normal statement, but I would honestly think that this is faster. And the reason I would say that this is faster is because this is built on top of NumPy. NumPy is built on top of C, which is a faster, just in general, language. So this is generally tends to be a faster way of doing things, is using the pandas notation. And using the base ands and ors.
Right. But if you wanted to do ors, you would have to go back to using the or inside brackets.
Yes.
If you only want
Yes. You have a question first? Someone over here? I thought. Okay, come on. Yes.
So how we created that totals column, how would we delete that? Since we created it, it was there, right? So
There is a command called del, which is also in this code base, but there is a command called del, that will remove an entire column, and I'll show you very soon. I don't want to do it just yet, though. So here, similarly, is the average European beer consumption, 193. Same notation, except I replace NA with EU. And guys, if you can make sure, stop me at 8:45 so we can start the lab, just in case I miss it. Thank you. Split, apply, combine. So the this paradigm of split, apply, combine is actually one of the bases for something called MapReduce, which is a paradigm for big data. Split, apply, combine is actually one of the fundamental ideas of Pandas. And to kind of show you what I mean by split, apply, combine, I have this nice little graphic right here that shows me how do I split, apply, and combine. So in this example, what I'm going to do is I'm going to find the average y column for every unique x value. So for A, B, and C, I'm going to find the average value for A, B, and C. So you can see for A, I have 2 and 4, the average is 3. For B and B, I have 0 and 5, the average is 2.5. And 5 and 10, I have an average of 15 divided by 2, 7.5. So the split, apply, combine paradigm works like this. The first thing we're going to do is we're going to split. We're going to split the data frame. Think of this as a data frame that has rows and columns. We're going to split the data frame by the x column. So here I have 3 different data frames. One with only A, one with only B, one with only C. Split. And then I'm going to apply. I'm going to apply the mean to each of those split up data frames. So I'm going to apply the mean here to get 3, apply the mean to here to get 2.5, apply the mean here to get 7.5. So I've split, I've applied, and then I'll combine. When I combine, I'll take my 7.5, my 2.5, my 3, and I'll create this brand new data frame with the result of my operation. So that's the idea of split, apply, combine. And it's done in Pandas using a function called group by. Group by is a way of saying, okay, split by continent, or split by whatever it is you want to split by. So how many continents do we have in our data set? 6. And you have 6 continents in our data set. So when I call, bless you, line 129, which is drinks.group by continent, I'm going to group by continent, split by continent, and then I'm going to apply to the beer servings the mean function. I'll say that again. I'm going to split or group by continent, and then to the beer servings, I'm going to apply the mean. So when I do this, it will split up my data frame into 6 data frames. One with only Europe, North America, South America, Oceania, Asia, and Europe. It will split into 6 different data frames. To each of those data frames, it will apply the mean function to the beer servings column, and then it will then it will combine all of them into this, what you see right here. So this is the result of a split, apply, combine. It splits it up into 6 continents because I told it to group by continent, and then it applies the mean function to the beer servings column. This might look familiar to you, because you might have seen this before. In fact, line 132, group by continent, and then I'm going to apply the count function to the continent. What that will give me is a count of the continents. And in fact, you've seen this before. This is exactly what the value counts method does. The value counts is a shorthand notation for a split, apply, combine, split by a categorical column, and apply to that same categorical column the count function. Value counts is a split, apply, combine. Why split, apply, combine? It is a very useful paradigm in what's called parallelization. It's very useful where we can split up a job into different separate tasks. So this is exactly how MapReduce and big data works. We can split up our data set into smaller ones, pass each of those smaller ones into different computers, and then combine them at the end. This is our first look into how we deal with very large data sets. We split, apply, and combine. And then in Pandas, it's done with a group by. Yes?
So group by essentially does both split and combine, but the apply is we have to pass a function specifically.
Exactly, yes. So the group by does the splitting, and it does the splitting, and then when we do dot beer servings dot count or dot mean, That's the combine and the apply right there. So line 136, group by continent, and then we're going to apply the min function to total servings. So what will that give me for each continent? And then we'll have the max for each continent. Whoa. Here, I'm applying my own function. I'm going to group by continents, dot total servings, and I'm going to specifically call the apply function. I'm going to apply my own lambda function, where it takes in a series x and it spits back the mean. This is the same exact thing as doing, just applying like dot mean. It's the same exact thing, but I can also give it my own function, which is nice because what I can also give it is for total servings, here's the standard deviation. Here's standard deviation of beer servings per continent. So now I can start to define my own functions. And the apply will take in a series and spit back a single number. Yes, Nick?
Can you explain the notation of lambda just a little bit more?
Absolutely. Lambda is a notation for creating a function. So a lambda will take in an input. So it's lambda space input, and then what it will return after the colon is some output. It's really a function. You could really say, if I say f equals this function, I could have another way of saying it, as I could just say def f with an input, return output. These are the same thing. Lambda is a shorter hand notation for creating a function, where it takes in an input and returns an output. So in this specific example that I'm highlighting, lambda x colon x dot mean, lambda is just the notation for I'm creating a function. Space x is my input, colon, what am I going to return? X dot mean. So in that lambda function, whatever I give it, x, it will return to me the mean of x. I could give it a list, I could give it a series, I could give it a tuple, I could give it whatever I want that could be applied the mean function to. Yes?
Can you quickly go back to the code? Can you quickly show us how, if we wanted to see what the country was for line 137, basically?
Okay.
If you wanted to show the country as well as the max, what the max is referring to. Can you edit this number?
Oh, so here's...
Like, is there a quick way to do it with this notation, or can you...
You can, I believe, if you can just type in country. Oh. Yeah. After max. No. I know if I put country dot total servings country. No, because that's gonna. I don't remember off the top of my head. Ramesh, do you know?
No, I was slacking.
Okay, thank you. Yes. I don't know off the top of my head. I apologize. Ramesh is going to put it on Slack. There is a way. There's definitely a way. It's by putting country at some point here, and I'm just kind of blanking on exactly where it goes, but we'll put it on Slack in a matter of minutes. But I can apply my own function. So, for example, range is not a function. The range being the max minus the min. So here, I'm going to group by continent, split, and to the total servings column, I'm going to apply this function, lambda, that takes in x and returns the max of x minus the min of x. X being a series. So for the series total servings, for each continent, I'm going to take the max of total servings, subtract the min of total servings, servings, and that will give me what's called the range of total servings, which is exactly this. So for Africa, the largest minus the smallest is 504. In Asia, the largest beer servings minus the smallest beer servings is 646. So on and so forth. Or total servings, rather. We can plot pretty easily too. Drinks.continent.value counts. Remember, this just shows us the counts for each continent. But if I call .plot with the kind equals bar, what it will do is it will give me a bar chart instead of just displaying the numbers. Pretty quickly and pretty simply. I can also change the X and the Y label, like in matplotlib. So now my X is labeled continent, my Y is labeled count, and my title is countries for a continent. Here, I'm going to do the split, apply, combine, split by continent, apply the mean function, and then I'm going to plot it. So this is, beer servings. This is average beer servings per continent. So instead of this, we did all this code before, except now I'm adding a dot plot. So instead of just showing the numbers, the means, I'm plotting them as a bar chart. We can make a histogram. This is a histogram of beer servings. Drinks.beerservings series.hist. It will automatically create a histogram with 20 bins. And I can change the number of bins to make it more quote-unquote refined. Here's it with 100 bins. Here it is with 5 bins. So we can specify the number of bins we want in our histogram to show us the distribution.
What are the bins? Sorry, what are the bins represent?
Good question. So in a histogram, the bins represent the count of that value in that range. So, for example, in right here, for each of these bins is like a range from 0 to 20. So what this is showing me is that there are 45 countries with between 0 and 20 beer servings. Here, there are 27 countries in the range 20 to 40. And then it keeps going, so on and so forth. They're showing us a distribution. So how we can read this is that most countries have below a 50 beer servings per person per year. More countries than not have a lower beer servings than a higher beer servings. This is what is called right skew. This is a type of beer called right skew because it has a large bump over here on the left. It's called right skew. Here's a fun one. Drinks.beerservings.hist by drinks.continent. This is like a split, apply, combine, except the apply is making a graph. So for each continent, it will show me the histogram of beer servings. So now this is broken up by continent. Now, does someone want to point out to me Africa, Asia, this is Europe, North America, Oceania, and South America. What are we noticing? Can someone tell me a basic, what do you notice on these graphs? Is it 45? Let me finish this graph. It'll take less than 5. Thank you very much. What do you notice on these graphs? Yes?
The y coordinates aren't the same.
So?
Well, if you're comparing country to country, then it looks like North America's average is less than Africa. The distribution's different.
Yeah. If you look at the distribution, if you look at the scales on your computers, Africa's Y scale goes from 0 to 35. What does the Y scale in North America go from? 0 to 4. The highest bar is 4 versus 35 in Africa. Does anyone notice these bumps in Asia and Africa? Does anyone want to tell me why there might be a bump on the left-hand side of Africa and Asia? What we're reading is that a lot of countries have 0 to very little average beer servings per person per year. Does anyone in Asia and Africa, does anyone take a guess as to why that might be the case? Because what?
They drink more liquor.
They lie. Well, the World Health Organization, well, there's a reason that they're reporting this, to put it that way. What might be a reason that African and Asian countries are reporting 0 beer servings? What do you think?
They practice religions that prohibit drinking.
Specifically, can you name one? Islam. It is prohibited to drink alcohol in the religion of Islam, as stated by the Prophet Muhammad. I should know that. I was raised Muslim. Most of these countries are Muslim countries, and they're reporting to the World Health Organization that no one is drinking beer, liquor, or spirit. Therefore, have total servings of 0 alcohol per person per year. And to your comment, these scales are also off, which is why in line 172 we can add share X and share Y to share the same X scaling. And when we do that, look at the difference of these bar charts. Now we can see when we add them all on the same scale, Africa and Asia are dominating the number of countries that are involved. Because Europe, North America, South America, and Oceania, they're very low bars. And to kind of finish up, we can do a density plot, which is a histogram, but a line curve. We can change the X limit to make it look a little different, same data. We can do a box plot. We can do a scatter plot of beer and wine. And this last thing is we can make a scatter plot, and I explained the colors. And we can make a scatter plot where all the European countries are labeled in red. Now, I am going to stop here. There is much more code to go through that has 2 different data sets to explore in your own time. But for now, what I would like us to do for the remainder of the class is work on O3 Pandas Lab. O3 Pandas Lab you should have if you did a git pull in the beginning of the class. If you don't have O3 Pandas Lab, please do a git pull now to get it. The way I would like to do this is I would like to split you guys up into your tables as groups, and I would like you all to work together to finish this lab by the end of class. Now we have about 40 odd minutes, 40 minutes, and there are 10 questions. A lot of these questions you have seen code for code already so far. All 10 questions is all about the drinks data set. And I've done everything I wanted to do for the drinks data set. So for the remainder of the class, please work in the groups at your tables. Work together, please work together, to complete, you guys can be moving on that. To finish this by the end of the class. See if you can finish it. Go! Yes. Sorry? On the lab now. Yes. Yes. Didn't get that. Hold on, let me stop recording for a second.
In the brackets